moderator for an awesome session today by Buck Woody, and just going through some of the presentation slides that we make so that you guys know where to connect with us, etc., etc. So this is the database professionals virtual user group, and our Twitter handle is DBA virtual user group, and the meetup is at this, and so on. All the details are here. Also remember this email, so DBA virtual user group at outlook.com. If you ever want to speak or have a suggestion, any feedback, bouquets, brickbats, anything, or you have issues accessing the shares where we have these presentations, just do send us the email to this address. I hope you guys are staying cool, but today being the fourth Wednesday, we are conducting this at the Pacific time. On the second Wednesday next month, it will be at noon Eastern. So, and you can find the recordings at this location here. Just scan this from your phone, and you should be able to go there very easily. No problem there at all. So our future sessions are coming up. You will love them, each and every one. I cannot even tell you which one is my favorite because they are all very, very awesome. Um, do go through these if you like any of them. Feel free to mark your calendars like now so that you don't miss out on such beautiful sessions there. And wait, they're free. So, and some events that are not part of the DBA virtual user group, but they are still huge in terms of learning, like you're drinking from a fire hose. And data Saturdays and SQL Saturdays are tremendous learning opportunities for you. Very few data Saturdays here in USA, but definitely SQL Saturday next month in Denver is coming up. And 4 days after that is the Future Data Driven Summit, which is 100% virtual. You don't want to miss out on those. Look it up. I will also be there moderating almost 4 hours and a few more sessions here. All these slides will be available in the share that I mentioned earlier. And to the next slide, Seattle, November 14 through 17. Please come. If you think you're learning too much today in this 1 hour, wait till you see more than 160 sessions on that conference there. Some awesome pre-cons are there Monday and Tuesday, which they're absolutely fabulous. If you want deep dives into anything, this is the place where you want to go. It's like the mothership of all data conferences. Okay, there is nothing similar to this in any other RDBMS technology. And without much ado, my good friend Buck Uri from Microsoft, he's going to be talking about that. And thank you, Buck. I don't know what happened here in the thing, but that's me and Buck last year at the SQL Saturday Dallas.
Yep.
And you determine who is the better looking, but he's definitely a smarter guy. And glad to be having him here. Buck, take it over, my friend.
Oh, no worries. Thank you,
And
my
I will go
friend.
on
And
mute. And yes,
yeah,
we are recording this session, which is almost always the question being asked. And that will be available on our YouTube channel as well. So, and if you have any questions, just type them. I will relay them over to Buck. So both me, Surbi, Teo, Julie, four of us will be monitoring this. So thank you. And I will take my camera offline now and the microphone as well.
okay, great. I'm assuming everyone can see my screen okay now. If you see generative AI on your screen, can someone type in the chat window that you can see that? Okay, good. So Teo said you can, so that's good. Hello, everyone. My name is Buck Woody. I work at Microsoft. Alpha, Beta, India, Romeo. Okay, well, all right then. It's great to see you here today. We're going to be covering a lot of information very quickly. I am watching the chat window so I can read those. I teach college, so I'm used to sort of this back and forth. So if you post a question there and I ignore it, it means that either I'm on a roll and can't stop, or I'm going to cover the answer in a little bit, but I will try and answer those. I'll answer them verbally since we are recording, and since you can all hear me, I assume, then we'll go from there. So what are we here to talk about today? We're going to be talking about generative AI, and that's a branch of artificial intelligence, and we'll talk about that too. And it can create new data or content by learning from the existing content. It has applications in a bunch of domains like text, image, video, audio, code generation even. In this session, what we're going to do is we're going to learn a little bit more about how AI works and then bring you up to how generative AI works. We're going to talk about the limitations, some of the main tools and processes that you have that you can use, and where you can use it to enhance your data projects, right? So we'll also explore some examples of how AI can help you write code, maybe do some debugging, optimization, that sort of thing. We're covering this from a data professional arena. So if you're a DBA, data developer, BI, this is going to be useful to you, I think. It is a bit of a different presentation, though. And Krishna, we will be sending that link for the recording and slides. We'll post that back up at the very end there. I have a handout for today we'll talk about, so we'll do that. This session is a little different than most that you've seen. So most of them are either how to, click here, type this code, and you learn that, you write notes and things. That's great. Another one might be conceptual and so on. This one is going to be one part college lecture. Sorry, I'm a college teacher, so we're going to make it fun, but we are going to be covering some things like history and so on. It's one part history lesson, so you kind of understand that, and one part sort of career technology focus. And here's what we're going to cover. We're going to talk a little bit about an introduction to AI, or artificial intelligence, which is the umbrella term. And we're going to talk about machine learning and what that is. We're also going to talk about natural language processing next and explain how that works. And then we'll go through generative pre-trained transformers, or GPT. So we'll be covering all those things. We'll then bring it home to where you can use it as a professional for how to use this stuff in your code, in your data, in your analysis, and so on. We're going to do Q&A, not at the end, but along the way. I'm watching the clock here. We have a lot of material to cover, so I won't cover it all. I can't. We just don't have the time, and many of these things, I always tell people we're going to open a lot of doors, but we're not going to go in the room and look in the closets and open the drawers. This is just not the time. But what I will do is I've got a curated set of resources in a notes view. I use the notes view quite a bit when I teach with PowerPoint. And so I'll give those to you and you can go read more. If you're like, oh, that was interesting, I want to know a lot more, then we'll go into that. We'll cover some things and I'll use some terms that you won't know. And that's okay. And I won't explain them because I won't have time. All terms and jargon are chunks, right? They're PK zipped ideas in our head that you need to go PK unzip to do these things. So we'll do that from there. So let me check and just see where we're at for people. Good, we've got a good crowd here. So we're going to move forward. Again, type your mics don't come off of mute. So type in your chat window if you have questions, and I'll either answers or not. Kit says there's not audio. Can somebody tell me if they are hearing audio? Say, yes, I'm hearing audio, and we'll know if it's
Yes, I
just
can
Kit
hear
or
you.
not.
No problem. I think it's a Kit thing.
Okay,
Kit,
so
you might want to adjust. Yeah.
Maybe we can chat to Kit and say, hey, Kit, you may want to leave and come back in, or check with your sound settings, right? We always have these problems. Great, good to hear. Glad it's clear and glad you can hear me. So this is what we're going to do today. Hopefully this is what you want to do, and we'll go today. So what's our goal then? If we're trying to do something, we should have a goal. And our goal today is to understand generative AI in the context of the AI history. I think it's important. As technical professionals, most of us can just go use things. I don't really know how to work on my car anymore. I used to back in the day. Nowadays, they're a mystery, but I don't need to know how a car works to drive it. But if I was a professional car driver, I'd want to know how a car works. And I think we're like that. As technical professionals, someone can say, do you know how to write AI? And you're like, well, I don't know how to write it, but I know generally how it works. That's what we're going to cover today. We're going to gain an overview today of GPT processes, how they work, and some of the designs that you'll see. Then we're going to put it to work. I'll show you some places this has got real legs. We've published some things where it really does work, and so on. Okay, so first of all, let's start with an introduction to artificial intelligence. There's some great overviews. Let me show you one of the links I have here. I've got a full set of cheat sheets available to you. where you can get all the different cheat sheets about how neural networks work and so on. I'll be showing you these resources as we go throughout, but I'll give you the links. So if I jump off of that link I just showed you, don't panic. I'm going to give you a list of all those in a PDF when we're done here. So let's start off first with, we'll jump in the Wayback Machine and go to 1956. And we'll start off with this idea of artificial intelligence. Someone probably needs to pop over and chat with Kit because he's still having a problem with audio. Maybe somebody can type in, he needs to drop and come back in. Artificial intelligence is an umbrella term. And basically it's this: any mathematical or formulaic technique that mimics human behavior. And that will give us what we call artificial intelligence. Now, I don't like that term. I don't like the word artificial because it's real. And I don't like the term intelligence because it's not intelligent. So, but that's the term we're stuck with. It's an umbrella term. And it comes from a paper, and we'll talk about that in just a moment. Now, as we think about that, way back in 1956, we move up to 1997 and we start talking about machine learning. And machine learning is a little more interesting. It's using combinations of mathematical formulas to act over data. So in other words, you don't write code that then accesses data. You take the data and throw it at the code, and the code can do a prediction, or it can do a classification or a grouping and some other things. And I'll explain sort of how that works. Of course, then we move on to our later environments where we have in 2012. And the idea there is we're talking about deep learning. And I'll explain how deep learning works a little. We get really mathy in there. If you like math, you'll be in heaven. If you're not good with math, you'll have to fight it. And by the way, I'm not good with math. I'm a data scientist. My whole degree and my work and my daily life and my money comes from math, and I fight it every day. I'm envious of those people who can just rattle off these math things. I have to fight it, but I do, and it helps. And then, of course, we'll move on to the latest thing that we've been seeing, which is generative AI. And it's right there in the name. It generates new information. All right, let's get started. We'll cover all of these things really quick. The first thing I want to show you is that there is, inside this idea of artificial intelligence, we have this statement from very early on, 1956. Human intelligence can be so precisely described that a machine can be made to simulate it. They literally believed, you know what, people do the same thing all the time, and they reason in a certain way. So why couldn't we do this? And so they began to come up with things to do that, but they didn't have the processing power, and they didn't have the data, and they didn't have the algorithms to do what they needed to do. So it went into what's called an AI winter, meaning that it just kind of died down and nobody talked about it. Well, people were still working on it. And in the 70s and the late 70s, when I came into artificial intelligence, now called good old-fashioned AI, we ran into this idea of something called symbolic development. Symbolic development deals with things like logic, fuzzy systems, simulation, expert systems. Expert systems are things where you find an expert and you say, if you do this, how do you know that? When the doctor says, oh, you've got a broken arm. How did you know you had a broken arm? Oh, well, if you twist it this way, it's painful. That means, oh, okay. So I can write that down. And then you could become the doctor. That's a little bit overselling it, isn't it? It doesn't quite work out like that. We did come up with some great concepts that are still in use. Things like evolutionary computing was the forerunner to sort of polymorphism that we have in our coding today. Now, as time went on, another AI winter. On Time Magazine, it was like, oh my gosh, AI is taking over the world. There's going to be robots that can talk and all the rest. Of course, that didn't happen. And we went into another AI winter, but then we came out of it fairly quickly because there were some statistical resources we had available to us. Inference, Markov chains, Bayesian normative theory, which is really useful and still in use. In fact, there's another resource I want to show you. Let me just pop over here. There's a great Time article, ironically, that talks about the A's disease of artificial intelligence. So if you need to put this into language that your bosses can understand, then I've got a resource for you there. All right, so we've got artificial intelligence, right? And the good old-fashioned AI and these ways of working with artificial intelligence. Now let's move on to natural language processing and generative pre-transformers. But we have to start first with machine algorithm families. Now, what is machine learning? Machine learning is a way of making computers sort of learn from the data. You don't explicitly tell them what to do. It's a branch of artificial intelligence that uses algorithms and statistical models to find patterns and make predictions. Some of these are examples are a web search, self-driving cars, speech recognition, and recommendation systems. If you like this movie, you'll like that movie, and so on. There's some key concepts that you need to understand. But before you do, let me show you some of these algorithmic families that you need to be aware of. The first one, and the one we use most often, quite frankly, is sort of the what we call the regression formulas or family of formulas. And these can help you predict how much or how many of something will happen. Remember, these are predictive. They use the past or data to predict what might happen in the future. That's probably the first thing we need to think about when we talk about artificial intelligence is it's a guess. It is not like select star and all the rows come back. Imagine you typed in select star from table name and it says, you know, the data could look a lot like this. You probably wouldn't take that, but that's exactly what AI does. It's making guesses, and you want to make those as good as possible. So the first one we use is regression. Regression simply means there's a couple of kinds, there's several kinds actually, looking at the past data and drawing a line or a curve or multiple curves to show where the data is generally headed. So I can look at the past and I can say, this is probably what will happen in the future. So that's our first one. Our second one is interesting. It's anomaly detection. Anomaly detection is quite hard. Now, in my college class, I often show this graphic and I say to my students, do you think that's an odd-looking picture? Are any of those objects that you're seeing on the screen? You're welcome to go ahead and type now into the chat window. Are any of those objects unusual? Do any of those seem, Fernando says the pen is unusual. Okay, good. And I'm assuming you mean that there's a pen in there and it's the rest of them are not pens. So that's a good guess. Anyone else? Is this odd or does it look normal? Anyone else? There's a red object. Okay, good. We're looking at color in that case. A clip. Okay, good. One of them's got a clip. Very nicely done. The green one is small. There we go. And Josh says
this. The other one is a mechanical pencil. So
Josh says this. Very interesting point. And Josh, you're exactly correct. It depends on the question. Because here's the question. If I say, look in my desk drawer and see what's in there, if you saw these, you would say, looks normal to me. But if I were to say, there are pencils in my drawer, are any of them odd? Are any of them not pencils? Now, the one on the far left may look like a pen, but it's actually a mechanical pencil. So in that case, they aren't odd, or actually they are, because only two of them are pencils. The rest of them are colored pencils, which are made of wax, not graphite. Do you see how it depends on the question? And that's so important. And I wanted to hit this early. When we're doing our formulas, we want to make sure we know what question we're trying to answer, because one formula, one answer. Not like business intelligence. I can't just take a bunch of data and say, go answer a bunch of questions. Doesn't work like that. All right, so this is another algorithm. Anomaly detection is very hard because anomalies are just that. There's not many exceptions in the data, and it's hard to train them. So our next group is the one we use quite a bit as well. It's called which category, or classification algorithms. We have binary classifications, things are or not something, and we have multi-class, which is what you see here. These items are birds go in one box, modes of transportations or cycles go in another, and tools go in another. So that's a classification set of algorithms. There's a bunch of those. We also have something called which group, or clustering algorithms. These algorithms don't have answers. The rest of these have been trained. We've shown them a pencil, we've shown them a pencil, we've shown them a pencil. Now we show them a new object and say, is that a pencil? And the algorithms can say, no, not from what I've learned. That's kind of how we learn, right? Your mom shows you a glass and she shows you another glass and she shows you another glass when you're a little baby. Then she says, what is this? And you say glass. And she's like, that's right. And then she shows you a ball and you say, glass. And she goes, no, that's wrong. That's exactly what we do with these other algorithms, but not this one. The clustering algorithm, we simply throw the data down and we say, group that together. And the thing says, well, how many groups do you want? That's called a centroid. And you say, well, I'd like 3 groups. And so it just tries to get things with as many features, which are like columns for us, that are the same or close together. It uses some vector math to do that, and it puts them into groups. And so, excuse me, that's how that works. The next algorithm we have is called reinforcement learning. And if you've got one of those little vacuums in your house that's round that runs into the wall and figures out your house, that's exactly what reinforcement learning does. In fact, the company that invented those, the iRobot company, that's exactly the algorithm they use, is a reinforcement learning algorithms. Now, these 5 algorithms form the basis of most machine learning algorithms we have. And now I've explained kind of how those things work. We use the data and the algorithms. Once we train the algorithms, meaning we send it a bunch of data, it tells us what it thinks, and we say, no, that's not quite right, and we change a few parameters, and we do it again and again. After we're done, we save that as something called a model, which is just a binary formula, if you will, that we can now show. The formula can be very small. We don't need all the data. It's already trained. You learn to read using lots of books, but you don't carry them around with you because you have a model in your head and you know how to read. You can read any book now. And that's exactly what machine learning does. It creates that model, and now it can look at something and say, is that a cup or is that not a cup? And it can say, my guess is that it's a cup, and I'm 80% sure of that. And that's the way these things learn. So we use this for a lot of stuff. Machine learning is used all over the place, and we have these things trained to do lots of things. Again, just going back to those columns, we call those the attributes: color, pencil, a mechanical pencil, and so on. We call those things features. Features are simply columns. And then we have a target variable called the label. Yes, this one's, if it's this and it has carbon and it writes and it's finger sized, that's a pencil. The yes, it's a pencil is what we call the label. And we use those for everything with the exception of our clustering algorithm, which doesn't need to know the answer because it's just going to start putting things in groups. You can see now why the data matters. The data matters because if I don't show it enough examples of both pencils and not pencils, and if I don't know enough to keep out for some testing, it's a very fine balance to get enough data. We're talking, gigabytes and terabytes of data to do this training. You have to see a lot of glasses to make sure you understand how those work. Okay, I think we've beaten that one to death. I don't see any questions on machine learning. Have a ton of resources for you to go learn more. But that's basically sort of the way that works. So now we move on. Now that you know that, we've learned artificial intelligence, which is the, sort of the umbrella term for all this stuff. We've learned machine learning. We now know how machines learn a little bit. Now let's talk about deep learning. What in the world is deep learning? It's a subfield of machine learning. So it uses machine learning algorithms, but it's a subfield of machine learning that uses something called artificial neural networks, ANNs, to learn from data. You throw data at it. Now, neural networks are composed of layers that are interconnected nodes. I'll explain more about those in just a moment. Each node is just another set of formulas, complex computations and formulas and transformations on the data that comes in. It's called deep, by the way, because it uses these multiple layers of these neurons or nodes to send the data on to the next piece to work with. Each one of those has its own parameters and functions, and it creates a big hierarchy, and it creates a representation of the data. So here's some key concepts you need to know to understand deep learning. The first is that outermost layer, which is the input layer. It's the first layer of a neural network that receives the raw data. The input layer can have different shapes and sizes depending on the kind of data and what we call the dimensionality. Like, for example, if the data is an image, the input layer can be a matrix of pixels with 3 channels, red, green, and blue. And then that is sent on to the hidden layer. What in the world's a hidden layer? Well, it's another layer of formulas, and it's any layer of the neural network that's not the input or the output. That's a cheater way to say it. That's the way it works. A hidden layer has different nodes. Some can be connected directly to each other. Some can be connected all over the place. It's called a fully connected network. They can be convolutional, meaning they go and come back. You can have recurrent networks, which go to one layer, go back to another layer, and so on. We'll see that that becomes very important in just a moment. Now, a hidden layer has these things called activation functions. What is that? So I've blown up one of the neurons here just to kind of show you what happens. The data comes in, and by the way, whenever we take apart a graphic picture, we lay that out into a single set of dimensions, and that is called, in mathematics, a tensor or a tensor. And you've probably heard a TensorFlow. We'll come into that in just a moment. Daniel says, would you have a node in each bit in a bitmap, or is there a way to use less inputs? Great question. And there's absolutely a way to use less inputs. We're going to talk about that. And sometimes it gets worse and makes more inputs. Something called one-hot encoding, very interesting term, can actually make something very simple very complicated. For instance, you and I might have a column and it says color, red, green, or blue, right? That's what we would put in a database. But these machine learning algorithms can't do that. There's no such thing as red. It's just a number. So I have to then have a red column, a green column, and a blue column, and put a 1 in it if it's red, and a 0, 0. Or if it's green, put a 0 and a 1 and a 0. Or if it's blue, a 0, a 0, and a 1. It's called one-hot encoding. So I can actually make it worse. So the answer is yes and absolutely not. It all depends on the algorithm types. Now, what this does is it creates something called an activation function. This particular one's called a sigmoid, and a sigmoid just says when it reaches this threshold, you can move it forward. Let me show you an example of this, by the way. Here's where we want to recognize a picture. We tear apart the picture into these tensors. And the tensor numbers then are sent through layers of the network. One might detect, I don't know, edges or shades of gray or colors or whatever it happens to be. As it works through the network, it then outputs an answer on the other side that says, hey, that's Diane. Because we've trained it on pictures of Diane, so it now knows what Diane looks like, and we can now say, okay, that's within the limit of what Diane is. It can look like this or this, and I still know that that's Diane. So that's the way these work. Once again, lots of math here, lots of things we have to understand. Now, one more concept I want to hit you with is something called back propagation. Oh my gosh, what is this word? A back propagation means I would like to calculate how close to the answer. Remember, I know the answer. So when I'm training this, I want to say, okay, this should be an edge. Is it? And I go check the answer real quick. And if it's not, I'm like, okay, well, let me adjust. So to go backwards and adjust, that's what I do. And I try to calculate something called a loss function. I want to go to where I start losing data the quickest, and then come back up with my algorithm. So this back propagation is a way for the network to move forward, but then go check its own answers and say, well, that was wrong. Let me try something else. And it sends it right back through the network. This back propagation is incredibly helpful. It uses something in mathematics called the chain rule. If you're new to that, I've got all kinds of resources for you to do that. We're trying to find what's called the gradient rate, gradient descent. It's how fast you're rushing towards problems, right? It's danger music. It tells you, oh my gosh, this is having a problem. Give me an acknowledgement in our, let's see if we've lost anybody. We haven't. Give me an acknowledgement if this is useful so far in the meeting chat, so I can either move faster or slower. Is this so far? Are you tracking? Does this make sense? I know there's a lot, and there's a lot we're not covering. So far, so good. Looking good. Yes. Okay, good. Perfect. All right. It's good. Keep going. It's fine. Okay, great. We'll keep going then. I always like to make sure you guys are still awake and you're not checking email or anything else. Mark, thank you for that. We'll move forward. All right. So what have we got? What have we got? We know artificial intelligence. We know how machine learning works, and now you're all experts in deep learning. You could go out and write back propagation and learning curves and chain. You could do that in your sleep now. Now we need to move to the next most difficult concept, and this is the concept of natural language processing, or NLP. This is a branch of artificial intelligence that deals with the interaction between computers and languages. This is a toughie, because languages are not exact, right? We know that in Hindi and English and Spanish and French and German, all these things, Chinese, Mandarin, and all these things can be very complicated and confusing. Rules are rules until they're not. There's lots of exceptions. It's really hard. But basically what NLP, natural language processing, aims to do is to enable computers to understand, analyze, generate, manipulate all the natural languages, either text or your speech. Some examples, by the way, of NLP are like chatbots. You'll hear that. Maybe translating. If I understand how Mandarin works and I understand how English works, I can now translate between the two of them. You can get sentiment analysis, because if I know how those work, now I can go from there. All right. There's some key concepts that we've got to understand. So let's start walking through these. I've got the process on the screen for you. You can kind of look at that as I explain each of these very important concepts. First, something called tokenization. Tokenization is the process of breaking down text or speech into smaller units, fragments of words or a couple of words together, and these are called tokens. They can be words, sentences, paragraphs, or even a symbol like an emoji. Tokenization is the first step in many NLP tasks, and it helps to standardize or simplify the input data. We chunk the word down. If you're familiar with how language works, we have gerunds and we have suffixes and prefixes and all these things. We do this in our head all the time. Now what we do after we understand the chunks that we have, the tokens, we need to parse them. Parsing is the process of analyzing that structure and meaning. This is the most important part, the meaning of text or speech. How in the world do you do that? Well, it involves different level of analysis, and you're using math again. Things like a semantic, syntactic, or even pragmatic, the way things are always used. Parsing can help to identify the parts of speech and how they're related. It gives them named entities. It can even give them the sentiment part or the intention of a speech or text item. For instance, we know that queen, king, princess, prince, all of that is something called royalty. How in the world do we do that? Well, you actually do that with vector math. You remember vectors from high school, right? You had your normal X and Y's, but you also have the Z. So you know like where somebody is located. They have you go to a certain street and a certain room in a certain house on that street, right? Upstairs and so on. You can locate in three-dimensional space using a vector. Go 30 feet this way, 20 feet that way, and 50 feet up. And that's a vector. So we do the same thing by telling the system queens, kings, princesses and princesses have a vector to each other. They are related to something called a concept called royalty, which is another token. Now I can say, tell me a story about royalty. And it will say, once upon a time, there was a queen and a king, and it knows how to do that. So that's parsing. That's a big step. The next part is something called embeddings. And what this does is, this is that process of representing the text or the speech as a vector of numbers in a highly dimensional space. So it's not just 3, A, B, and Z. It's literally hundreds or thousands or tens of thousands of those. Embeddings can capture that semantic and syntactic features of text, and it can also find out the similarity or dissimilarity with other text. So embedding can be done using a lot of methods these days. There's a library called Word2Vec, Glove, BERT, or something called GPT. So we'll come to that in just a moment. Now, the generation part is the process of producing text or speech from an input or a context. Generation is the process of producing the techniques that like are rule-based, or maybe they're template-based, or maybe they're neural network-based. They can be used for a lot of things. We can summarize, translate, we can answer, we can create new content, and so on. And finally, you need to measure the performance. Now, when we say performance, as a data scientist, I'm not talking about how fast something works. I'm actually talking about how well it works, not how fast it works. So that's important. All right, now you're an expert in artificial intelligence, machine learning. You understand now how to do natural language processing. Let's go for broke here. We'll have a quick little quiz. I need for everybody to evaluate the screen there. We're going to talk a little bit about the transformation step. So just look at that and I'll give you a quick test. If you don't pass the test, then you fail. No, I'm kidding. There's no way you can pass all this. It is so hard to understand these things. But let's talk about what we're doing here. When we take those large language models, the GPT parts, the generative I generate, pre-trained, I've looked at a large amount of data. Basically, that's what's called a large language model, or an LLM. That's a machine learning model that's trained on a large amount of text data to learn the patterns and the structures of natural language, how we normally speak. Large language models, or LLMs, can perform various natural language processing tasks. They can generate text, they can summarize things, they can answer questions intelligently, they can do sentiment analysis, and they use a single model to do that without having to be trained on just that one thing. Is that Diane? We can actually train it on a ton of stuff. So how do we do that? So the generative part is I can make new things. The P part, the pre-trained, is the process of training large language models on a general purpose set of text. We call this a corpus, or a body, right? We can look at Wikipedia, books, news articles, web pages. It basically aims to capture the common knowledge and the linguistic features of natural language and then store them inside the model's parameters, those things that are coming in that you saw earlier. Now, this is used on something called self-attention. What on earth is this? This is based off of a paper that was released from Google. It's a mechanism that allows large language models to have the relationships and dependencies between different parts of the input text codified. So self-attention works by computing a score, this is bizarre, for each pair of tokens in the input text based on how similar they are and how relevant they are to each other. And then it uses those scores to create a weighted representation of the text that captures the context and the meaning. Okay, we've got the generative part. It can make new things. It's looked at lots of other things, and then it uses something called self-attention, bunch of math, to put things together to learn the relationships. And now we have something called a transformer. That's actually what you're seeing on the screen there. That diagram that you see there is very similar to the deep learning diagram I showed earlier. It's a type of neural network architecture, and it's based on self-attention, and it's got two parts: an encoder and a decoder. The encoder does all the work of taking the input text, right? And it encodes that into a sequence of vectors. And it uses that self-attention we just talked about and something called a feed-forward labor. I learned this. I'm going to give it to the next layer, do this, and so on. So then that stops. It's encoded it. I've got a bunch of binary data. The decoder takes that and generates the output text of what you want using the self-attention and feed-forward layers. And basically, BERT, GPT, all these other things that do these things, that's how they work. They take and they take the text they've been trained on, then they turn that into a series of encoded ideas. And then when you say, tell me a story about the royalty, it uses that to then turn it back around and decode that into something else. And that's the way those work. Now, it's very important to understand the scaling that's done here. And by the way, the chips that these things are trained on, you need thousands of these chips to train this stuff on. Each of those chips is over $40,000 each. This is not cheap. It's not a cheap thing to do. And we're talking a lot of data. GPT was trained on most of the internet. GPT 3.5 was trained on way more, and GPT 4 is even bigger, and it's pretty stunning. These things are taking in billions and billions. I feel like Carl Sagan, right? Billions and billions of inputs and tuners to make this stuff work. Now, I've got the most resources on this page, so we'll go from there. Now, earlier I said we made this general model that understands sort of English. Kit says glitchy, okay? Right, and somebody's brain is melting. I haven't started yet. We haven't gotten to the hard stuff. No, I'm kidding. This is the hard stuff. There's some more hard stuff. All right, here we go. This thing makes a model. Yeah, these transformers more than meets the eye. There's something called a foundation model. Stanford University invented this term called foundation models. And foundation models, basically, we train them on one corpus of data, but they can do lots of things, more than we thought. Question answering, sentiment analysis, information extraction, image generation, image detection, and so on. I've got another resource for you here. By the way, there's another machine learning algorithm resource that I'll give you from Azure, which I helped work on. I was part of the Azure ML team when we built Azure ML. So we've got a great little thing that says, hey, I want to extract some information, or I want to get recommendations and so on. So I've got that. So we've got those there. The foundation models is a great paper I have for you from NVIDIA. NVIDIA, very, very intelligent folks, and they'll explain kind of more of what a foundation model is. And there is some stuff we need to think about on these foundation models. There are some risks, and we'll talk about what those risks are in a minute. But let's talk more now about how we use these things. Let's go to a real live example. So I can actually ask GPT, how do you work? Tell me more about yourself, GPT. What's a foundation model? And it will interact with me. Now, you'll notice that it has a bit of a memory, right? It has some inputs that it can take from me. Only a certain amount of these inputs can it take in. After about 20, it starts losing its memory, but there's ways to augment that. But basically, we can chat with Bing and say, what's a foundation model? The questions we have here in the blue bubbles, based on my question, it goes and gets the stuff from the internet. By the way, we always reference where we get stuff inside Bing. Bing is using GPT to do that, and then Bard from Google uses their own model. And so the idea is it goes out and can follow what you're asking. If I were to say, what are the main colors in the rainbow? And it tells me, what about that third one? You can say, what about that third one? And it will remember what you're talking about, and it knows the context of what you've asked, and will go talk to you like a human. Unbelievable stuff that we have here. Now, I wanted to vector off here, to coin a phrase, a little bit and start talking a little bit about some emergent behavior. This is something we didn't really intend. We built these models and we trained this data to do one thing, and then we found out it could do more things that we didn't know it could do. Remember those hidden layers we talked about in deep learning networks? You can't look at those. We don't get to see them. You can't ask them what they're doing. And we just say, here's how many epochs, and go train and go learn. And it's like a pachinko machine, if you know what that is, where you put the little ball on the top and it hits all the nails, and you don't know where it's going to hit at the bottom. Now, interestingly enough, in a pachinko machine, if I drop enough balls, it will make a perfect curve every time, because that's how the universe works with averages and bell curves and Bayesian theory. However, that individual one, I cannot predict where it's going to go. And so the nails are like those hidden layers And so it can begin to do things. We tell it, I need you to translate something. And it goes, oh, you want me to tell you a story? And I'm like, you can tell me a story? So if you open up chat inside Bing, if you go inside the Edge browser and open up the Bing chat feature, and you say, make a bedtime story for me that involves 3 people, one of them older, one of them younger, one of them from out of the country. They're going to the big city for the first time. They're nervous. They run into trouble, but in the end, it all works out. If you type that in, you will literally get this amazing story back out, and it will creep you out that it can come up with things that it will appear magical. It's not. It's not. However, these emergent behaviors can be interesting if I know Chinese and I've trained on that language, or Mandarin, and if I know English and I've trained on that language, then this thing can do translations, even though I didn't say make a thing that can translate from Mandarin to Cantonese or English or French. But because it knows those, it creates emergent behavior. Do you get college credit for today? Yes, not from a college, just from me. I do teach, but you're not in my class, so you don't get any credit for this. That I want to make sure we understand, though. There's some dangers here, right? There's some emergent behaviors. Now, it's not going to come out and start shooting people in the streets and say it's looking for Sarah Connor. That's not what we're talking about here. It's not that. It's just that I was talking with a lady on the airplane one time, and she said, are you afraid of what AI can do? And I said, no, I'm afraid of you. I'm afraid that you'll believe it and you'll do something stupid. I'm not afraid of the AI telling me things. I'm afraid you'll believe it. Because it can be wrong. The difference with GPT is it will always generate something. And by the way, that's why it's not very good at math, because math isn't English. It's read a whole bunch of stories. And you may have read a story on the internet where the detective goes, well, 2 and 2 don't equal 5, Missy. And now when I say, what's 2 and 2, it goes, 5, because it's read that story. So you've got to be extraordinarily careful about how you deal with these things. We don't want to trust them. All right. So I think I've scared you enough with that. Let's go now put this back to business. Let's go take a look at putting the AI sort of to work at this point. All right. You understand what artificial intelligence is. It's basically just anything that happens that looks like a human would be able to do it. You understand how machine learning works. It's a series of algorithms, a bunch of data with the answers. You run it through the algorithms. You say, yes, that looks correct. And it says, okay, I'll make a formula out of that. Or you say, no, that's not right. And you change some parameters. By the way, we call these hyperparameters because that sounds a lot cooler. No, there's a real reason for that, but we do put the word hyper in front of it. It's not really hyper. They're not really busy or anything. There's just different parameters that it uses. And we tune the model and we retrain it. And maybe we go, this is the wrong algorithm entirely. Let's use a logistic regression, or let's use a standard regression, or whatever, right? So we change our algorithm. Once we like our model, then we can send a bunch of that data through and we'll get a prediction of whether it's right or not. We can then layer those in and we can make our deep learning that can recognize things that we wouldn't normally recognize, speech, pictures, music, and so on, because we can turn everything into a series of tensors or math that we can use for this. All right. Then we learned about natural language processing and the importance of encoding. We learned a lot about how we need to bring the data in and make tokens out of them, and so on. Once we did that, we've now learned about how we can turn that around, encode that into something, and then decode it, and that becomes our generative pre-trained transformers, GPT, and that's what those work. So where can you put it to work? Well, we have a few places, a couple at least that I want to go over today. We got about 15 minutes left, so we're right on schedule here. The first thing we have is the OpenAI service. So here we have a bunch of things available to you. We have GPT models, which can do text. We have DALL-E, which can do images, creation of new images. We have ChatGPT, so you can do things like have bots that can talk with you. And we have ChatGPT 4, which can do some really stunning things. We also have the ability for you to bring your own data into these things. So it's great that it trained on the internet, but gee, I'd love to train on my corporate documents and stuff. We have the ability to do that. We have plugins. These are things which may go, I don't know, analyze all your mail and see who's asking you to do things or create replies for you or whatever. We have content filters. So if people are sending you things that are inappropriate, you can filter that out. And we can say, spend a lot of money or don't spend much money on doing these things. There's a huge toolbox we have available. I think I've got another resource for you on this one. Inside our Azure. Yeah, the OpenAI service. So we've got a bunch of documentation. Again, I have all these resources for you. I'll put them at the end here. We've got a bunch of quick starts for you, how to do embeddings, how-to guides, training. Got a ton of training for you for free. How can I enable ChatGPT for Bing? If you open the Edge browser, which I've got here, and you click on that little icon right there, you're now using ChatGPT. Here we go. I'll tell it to be creative. And by the way, this is a color setting. And I'll say, tell Paresh, tell me a story, this is off script, y'all, about a young boy named Paresh who keeps interrupting his teacher. And we'll do that, and we'll let it spin so Paresh can learn how to do this. By the way, you can also just go to bing.com, and if you click on the chat thing, here's a story I made up about a young boy named Paresh who keeps interrupting his teacher. Paresh was a curious and energetic boy, and you see that one day his teacher was teaching them about the solar system. Paresh looked at his teacher and said, blah, blah, blah. And so we've got a little story here about Paresh. It's still going. I will paste the output here in just a moment. And once it finishes telling me the story, and you can see it still telling me, I have one of 30 prompts I can use, by the way. It can remember up to 30 things. Like I could say, add in a young girl to the story, and it would add in a young girl for Paresh. So it's written me a book here. I'm going to publish this. It's a bestseller. I'm copywriting it. Actually, you can't. So it says, here's the end. So let me just paste the story. I don't know if Teams will let us paste this much data, but you can see the kind of things that it can do. So that's how you get to ChatGPT. You don't have to pay for that. That's a freebie, and so on. Okay, let's get back to the session. We're way far away from the session. All right, so you can do a bunch of things inside the OpenAI service. This is an API call that you can make that will do these things. Now, where can you use it for data? All right, here we go. Here's the thing we need to learn. The first thing you can do is you can use GitHub CoPilot. What in the world is CoPilot? CoPilot is a codex of software that can do work on a database. I won't give you a demo today. We don't have the time to do this, but you can open Azure Data Studio and you begin to do things like I typed in the select statements and it figured out the inner join I might want. I typed in a comment here, pivot that query on token color for purple, blue, green, yellow, orange, red, rename the columns to match the colors. And it literally comes up with the pivot statement. I don't know about y'all, but the pivot statement, yeah, the $19 a month if you're going to use OpenAI. Just to use chat in Bing, it's free. The idea here is I told it what I wanted in the comments, and it wrote transact SQL statements. And are they perfect? No, it's a co-pilot. I always call this a ninth grader that you're checking their homework, but it can do a lot of work for you. Let me give you another resource here. Hold on just a sec. I have a full learning module that you can learn about Copilot, and this is free, and it shows you exactly how to set it up, how to get connected, and so on. This does cost money. So if you want to do this one, this costs a little bit of money to do that. All right. What else can you do? Well, you can actually integrate it into SQL Server. Let me show you how. The SQL Server Machine Learning Services, it is a subsystem inside SQL Server. that uses a framework, the extensibility framework, to run Python, R, Java, any language you'd like. We include Python and R for you. There's a full document set for this. Here's the way the extensibility framework works. You call a certain stored procedure. You tell it the language you want to use. It goes and invokes an engine. That engine then runs the code that you told it to run, R in this case. And in this case, I'm not doing anything very exciting. I'm taking what I sent it and turning it back around. And then it sends it back to SQL. So you're very secure. It never leaves SQL. All your data stays in SQL. It's a secure memory channel, never goes out over the internet. Very useful. I've got some resources for you to go learn more if you'd like to do that. So I took a look at that and I said, I wonder, since I can talk to OpenAI I can do that inside SQL Server, and I can then talk to OpenAI with Python. Why couldn't I put those things together? And you can. So we've got a demonstration that you can see out there where I've used machine learning services to take AdventureWorks, get the name of a bicycle, and I told it to write a marketing campaign like the story for this bicycle so I could use it inside an advertisement. And it completely wrote my ad copy for me, and I'm not an advertising executive. And I can do that with a stored procedure, so very useful. Not the end of the story. Inside Azure SQL DB, we have now REST endpoints you can call. So my good friend Davide has a blog series where you can go look at it. By the way, here's where that is. So here's that notebook I made. You can go out and find that, and it's in my resources that go from there. And you can see where I use SQL Server and ML services to go make that. And it's real time. You can actually run the code yourself and do it. Now, that's not all. Wait, there's more. With this REST endpoint that we talked about, you're able to call out from SQL DB and talk to containers, Azure Functions, API management, Power BI, Fabric, and OpenAI, and all of our cognitive services as well. We have 6 minutes left. I want to show you something and then take any questions that we have. This is the one other thing I should mention is OpenAI can actually work with your own data. So I've got a resource for that that's here. And then I've got the GitHub. Let me zoom in for you a little bit. That's all it really takes right here is all it really takes. My friend Davide, who works on my team, wrote about how you can invoke a REST endpoint to do this stuff. Okay, let me go to the last slide here. There we go. Thank you for that. I'm going to turn off the sharing for a moment. Will the deck and the resources be shared to the participants? Yes, it will. I'm going to do something here. The moderators don't know I'm going to do this. I'm going to try and do it. Hold on just a second. Let me see if I can. No, I can't. I was going to share a file, but I can't do that. So I'm going to send it to them. Let me share my screen again. Share that screen. Let me open something real quick, and I'm going to show you what I'm going to share. On just a moment, everybody stay calm, nobody panic. This is the whole, get out of there. This is the whole deck. Let me zoom in. Boom, 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 boom. The whole deck you just saw. And it's got every slide I just showed you, and it's got all of the resources that I was explaining. Every one of them is here. The cheat sheets, the artificial intelligence explanations, all of the math, all of the resources, the pre-trained algorithm families, how they work, more information you can do here, tons of resources for this. And of course, this one has an absolute ton of references. This is one of my favorite, by the way, the Wolfram Alpha. I don't know if you know of Wolfram Alpha. This guy's amazing. And he wrote an article called What is ChatGPT doing and why does it work? And he goes into the math. Now, I spared you of that. You should give me extra points. I don't get paid anymore, but you should give me extra points for coming up and not giving you all the logarithms and the vector math and the centroid calculations and so on. So anyway, that's there. I'm going to stop sharing again. I will send that to Teob, and he will get it to everyone that wants it. Good stuff. Apologies, we didn't have time for demos today. It would take hours to show this. When you use those tools, does it mean AI is ingesting your data? No, we do not, and ChatGPT does not. OpenAI does not take your questions to retrain. We don't do that. Yep, we've got. And yes, there's so much things that you're doing. We have the one where you can use your own data for training, but you will own that model yourself. We won't have access to that. So much info. That's very true, Mark. It's a lot. Great stuff. Ravi, thank you. I will turn it back over to the moderators at this point and let you guys take us out. Paresh, you may come off mute and regale us with tales of daring do.
Cool. So, hey guys, thank you very much. And Buck, I mean, I can't thank you enough for doing this. Had I not predetermined what I was going to say, my mind was already kind of melted into a curry pot. So I would not have been able to say this. But thank you very much. And everybody here, I mean, over 100 people attended today, which is phenomenal for us. And I look forward to seeing you again, hopefully in
Fantastic.
October, I guess. Yeah, October 20 or something like that, right? Looking forward, guys, and keep pinging us with any questions, comments, bouquets, brickbats.
Yeah.
Tweet about us, tweet about the topic,
Yes.
what you like to see, what you like to hear. We already have speakers till January 2024 and maybe February, unless
yes,
we have got
Paresh,
somebody signed up for March as well.
Fantastic.
Paresh, do you mind put the recording link, because it's just our YouTube channel, so
Yeah.
folks can check there maybe over the weekend once we upload it, and I will send the file to everyone who attended as soon as I
Fantastic.
get it from Buck. So
I'll get that to you, the information. And once again, to all the attendees, thank you so much for attending. It's an hour out of your day. I hope it was useful, and I hope you found something in there that you're like, I want to go learn more about that. And I want you to do it. At the very least, go use the information, but I'd love you to learn a little bit more about how it works.
I'll stop the recording now, though. Give me 1 sec.
Fantastic. Okay, thank you, everybody. I'm off to
Yes,
another
and I
meeting
have
here at
to
Microsoft.